Microplastics have been recently included as emerging pollutants, especially because they are very effective in incorporating contaminants and spread them within the environment. Actually, rivers are considered as a kind of conveyor belt to transfer microplastic from the land to the sea. Nevertheless, during this transfer, microplastic can be stored in sediments where they are able to stay for even a long time, and they can be further fragmented, and they can also interact with biota. We are actually interested in mechanisms which are controlling the transfer of microplastics within river channels. And especially, we are interested in mechanisms which are able to trap microplastics within sediments. In this framework, we decided to investigate a segment of the Arno River in central Italy with a new approach. We applied principles of fluvial sedimentology, aiming at understanding how a river can move microplastics and can store them within different types of sediments, including mud, sand, gravels, and even plant debris.
So in our laboratories, we develop a procedure to separate the microplastic from the sediments. And this procedure is based on the different in density between plastic and sedimentary material. And we extracted the fragments of microplastics, we isolated the fragments, we went to the microscope and to the Raman microspectroscopy, and one of the most striking results is by far the most abundant fragments are given by fibers. So 80–90% of the sediments is deriving from textile material.
Large concentration of plastics have been found in association with the floating plant debris, confirming the suspension as the major mechanism for the transport of microplastics. In addition, we have observed high concentration of microplastics in association with gravelly deposits, where the strong flows which mobilize the gravels prevent the settling of lighter sediments. Nevertheless, during the waning phase of the flood, the temporary permanence of the flood water at the same level allows the infiltration of microplastics between the gravels, where they can settle in a shaded zone.
The presence of microplastics was also examined in sandy and muddy deposits. It is somewhat intuitive to expect to find microplastics within fine sediments associated with settling processes. However, their common occurrence in sands suggests that these particles are easily entrapped within sandy bedload. Microplastics can be found in sands because sediment grains can adhere to microplastic surfaces, creating different aggregates with higher density that could be transported as distinct particles forming the bedload. Another reason could be that they can be removed from suspension and buried in the deposits as they are trapped within sand grains.